am Renu Sharma, Assistant Professor, EC Department. Today, I am going to start with the next topic of the subject, that is wireless and mobile communication. The topic of today's lecture is diversity techniques. So, these are the topics that we are going to cover today, that is different types of diversity combining techniques, like first one is selection combining, threshold combining, equal gain and maximum ratio combining. And also there are different versions of diversity technique, like first one is spatial diversity and another is the multiplexing in MIMO systems. So, diversity technique are used for improving the reliability of a message signal by utilizing two or more communication channels with different characteristics. So, multiple versions of the same signal may be transmitted or received, and these are combined in the receiver. Like in case of diversity techniques, in case of multipath propagation, all the signals which are received at the receiver will be delayed by some amount and also with some time instant, and also different versions of the signals will be received. So, in this figure different independent fading paths are shown with different CIRs, carrier to interference ratio, that is H1T to HNT, and the distortion in the signal is observed due to addition of interfering signal, that is I1 to IN, and white Gaussian noise. So, white Gaussian noise, it is nothing, it is the noise which is been added at the channel, and then it will going to provide the noise. The strongest signal is then picked from the received signals, like this is ST. Now, ST is the signal that we have transmitted. Different filters are there which is having their transfer function H1T to HNT, which means n different branches we can connect if there are n number of different signals that we have received. Now, and then the demodulated to receive the digital signal with minimum bit error rate. Now, these are the different interferences that are being added at this side. This is AWGN, that is additive white Gaussian noise, and these are the different received signals, that is Y1T to YNT. Now, signals used for combining and equalization. So, this is the different diversity techniques that we have seen over here. Now, diversity combining is the process to extract the main transmitted signal with minimum channel effects out of many versions of a signal that has been received. Depending upon the type of fading, like different types of diversity techniques are there, like micro diversity technique, macro diversity techniques are there. So, in case of this micro diversity technique, these techniques are used in a small scale fading environment. Two antennas are separated by a fraction of meter. So, in this case micro diversity and macro diversity is there, like whatever transmitter that has been connected, it has to be separated by some amount of distance, like in case of this one micro diversity, it will be separated by a fraction of meter. In this case macro diversity, these techniques are used in large scale fading. So, small scale fading means when the distance between the transmitter and receiver is quite less, and diversity means when the signal is being received from different path. In case of this micro diversity technique, these are used in large scale fading environment. Antennas are quite far apart and these are not shadowed, which means in case of macro, the distance between the between two antennas or three antennas will be quite large as compared to the micro diversity one. Now, the different diversity techniques are there, like first one is the space diversity, another is polarization diversity, angle diversity, frequency, time and joint diversity. In case of space diversity, microscopic and macroscopic diversity techniques, space separation of half of the wavelength is sufficient to obtain two uncorrelated signals. So, these are the different types of diversity, like first one is space. In this one it may be a microscopic or macroscopic. So, the separation of half of the wavelength, that is lambda by 2 separation is there between the two antennas, that is between the two transmitters, and it is sufficient to obtain the two uncorrelated signals. So, that is the case of space diversity. Another one is the polarization diversity. So, the obstacles scatter waves differently depending on the Polarization. So, polarization means the signal that has been transmitted, it will be polarized by some angle, means it will be scattered by some angle. So, antennas can transmit either a horizontal or a vertical polarized wave. When both the waves are transmitted simultaneously, the received signals will exhibit uncorrelated fading statistics. Next, third one is the angle diversity. So, the received signals arrive at an antenna via several paths. So, angle diversity means each with a different angle. Let us say this is the receiver and all the signals will be received at a different angle. So, this is the first angle, this is the second angle, third one is this one angle. So, different angles it will be received at the receiver side. So, that is known as the angle diversity. Another one is the frequency diversity. In this, the information is transmitted on more than one carrier frequency, because the frequency separated by more than the coherence bandwidth of the channel, it will not experience the same fading. So, that is the frequency diversity. Next one is time. Time is multiple versions of the same signals are transmitted at different time instants, which means that at different point of time the different time versions are like let us say we have transmitted the signal at instant time t, then we have received at t minus t, we have received at t minus 2 t, we have received at t plus t, we have received at t plus 2 t. So, these are the different versions of the signals that we have transmitted. Joint diversity is combination of above mentioned techniques. So, which means any of the combination, like we can either take 2 diversities, we can take 3 diversities. So, these are joined together to provide the combination of above mentioned techniques. Now, diversity combining techniques are there. Space diversity reception or combining methods can be classified into 4 different techniques, like first one is the selection combining, second is the threshold combining, third one is maximal ratio and fourth one is the equal gain combining. So, these are the 4 different combining techniques. In case of the selection combining, it is one of the simplest kind of diversity technique, which is explained by this particular diagram. It is based on the principle of selecting the best signal, which is having the largest energy or largest signal to noise ratio among all the signals which are received from different branches. Now, you can see that these are the different receiver antennas, signals will be received from different paths. These are the antennas. Now, these are passed through different path which is having different gains like G1, G2 up to Gm. So, these are the different gain through which the signals will be passed. Then this is switching logic or demodulators are there, which means it will going to check that different signals that are passed through different gains, because the value of G1, G2 up to Gm, let us say 4 different gains are there, the value of all the 4 signals will be different. So, these are passed through this particular different parts, then this is switching logic or demodulators are there, and finally, we are going to receive a particular output. So, this is the selection combining technique. Now, next one is the threshold combining. So, threshold combining is a special form of selection diversity that is less expensive to implement. Here a limited number of signals are considered for the extraction purpose using a threshold level. So, in this case threshold combining, a particular preset threshold is applied to a comparator. So, whatever signal which we have received, it will going to be checked at the comparator, and it will going to compare with the preset threshold value. If it crosses the particular threshold level, then it says that particular signal is received with a good quality, and if it is not, then it is not received with particular quality. Then scanning and feedback mechanism are used there. So, this is the threshold combining technique. Like you can see over here, like these are the different antennas which are connected at the receiver side, and this is the switching control, which means it will going to switch at this particular antenna, it will going to switch at this particular antenna. Now, this is received at this particular receiver. Now, this is applied to a short term average, which will going to take the average of all the signals that are received at different paths. Now, this is applied to a comparator. To this comparator, there is a preset threshold value is there, which will going to compare that yes, particular signal has been combined or not. Now, next is the equal gain combining. In case of this equal gain combining, it is better than the selection diversity, and it is almost as good as maximum ratio combining technique. So, but it is less complex in terms of the signal processing and feedback paths. Now, you can see that all the different signals, means all the different antennas are there at the receiver side, like m number of antennas are there. This is passed through different gains, which is having the different variable values, like this is G1, this is G2, this is up to Gm. So, m number of gain weighting elements are there, which is having their different values. These are variable, means these are adaptive in nature, and how we are going to change its value? By taking the feedback. Now, this is cophase and sum has been calculated, and the output will be generated by this equal gain combining technique. Now, the last one is the maximum ratio combining. This is for noise limited systems without interference. MRC results in the base signal to noise ratio. Now, you can see that what is the difference between this diagram and the previous one. Like you can see that here a detector is connected, which is missing in the equal gain combining technique, where all the gains are having the same value. But in this case, maximum ratio, the gain, the value of these gains will be combined by this detector. So, here all the incoming signals from all the m branches are weighted according to their individual signal voltage to noise ratio, and then these are added together. All the individual signals must be co-phased before being added. So, this requires an individual receiver circuitry and a phasing circuit for each antenna element. Now, you can see that m number of different branches are there, these are applied to different gain techniques. Now, this is applied to a co-phase and sum system, where different branch weights we have to calculate using the feedback of this detector. Now, output of this detector will be the, it will provide an signal to noise ratio acceptable compared to the other techniques. So, this provides a maximum value of signal to noise ratio, which is received at the receiver side. So, this is the maximum ratio combining technique. Next one is spatial diversity and multiplexing in MIMO system, that is multiple input multiple output technique. So, presently 4 different types of multi antenna systems can be categorized on the basis of diversity. First one is single input single output, which means there is no diversity. See, diversity is where multiple antennas are there, where whether it is multiple transmitter antennas are there or multiple receiver antennas are there. Now, that is known as diversity technique. In case of single input single output, that is SISO, there is no diversity. In case of single input, multiple outputs are there, like there are single transmitter and more than one receivers are there. Now, these more than one receivers are known as receive diversity. When more than one transmitters are there, like 3 transmitter and 1 receiver is there, then that is known as transmit diversity, which means more than one antennas are connected at the transmitter side. When more than one antennas are connected at the transmitter as well as the receiver side, that is known as MIMO or transmit receive diversity. So, these are the different diversity techniques. Next is comparison of channel capacities of various multi antenna systems are there, like first one according to the Shannon, the limit on the channel capacity is given by this particular formula for the SISO system, that is single input single output. Here C is equals to W log to the base 2 1 plus signal to noise ratio. So, this is when there is no diversity is there, means single antenna transmitter is there, single receiver is there. So, we are using a very common formula given by Shannon, that is capacity of the channel is given by W, W is the bandwidth log to the base 2 1 plus signal to noise ratio. Second formula is for single input multiple output, means multiple receivers are there, then we have multiplied by this N is number of transmitters, M is number of receivers are there. In case of SIMO, this M receiving antennas are there. So, this will be multiplied by M signal to noise ratio. In case of this MISO, that is multiple input single output system, N transmitting antennas are there, which means N number of antennas are there, and in the case of transmitter, which will be multiplied by N. Now, MIMO in this case, N transmitter and M receiving antennas are there. So, this will be multiplied by M into N, that is M number of receivers and N number of transmitters are there. So, that is MIMO system. Now, next is what is MIMO system. MIMO offers greater spectral efficiency as compared to SISO, single input single output, single input multiple output and multiple input single output system. Higher data rates, greater range, increased number of users and enhanced reliability. So, these are some of the advantages of using the multiple input multiple output system. Since we have used multiple number of transmitters and multiple of receivers, so it will definitely going to cover a greater range. It will increase the number of users which can use a single common channel. Also, its reliability will be increased. MIMO system consists of several antenna elements plus adaptive signal processing at both the transmitter and receiver. It will going to exploit the multipath instead of mitigating it. So, multipath concept will be used at the transmitter and the receiver side. Now, spatial multiplexing in MIMO, the underlying mathematical nature of the spatial multiplexed MIMO is there, where data is transmitted over a matrix rather than a vector channel. Now, you can see over here that this is the transmitter, this is the receiver, there are two transmitters are connected, there are two receivers are there, creates a new and enormous opportunities beyond just the added diversity or array gain. It will going to benefit the spectrum efficiency. So, the efficiency of the spectrum will be improved by using this particular MIMO technique. Now, this is the spatially multiplexed MIMO system is there. In this particular diagram, this you can see that we send multiple signals, the receiver learns the channel matrix and inverts it to the to separate the data. Now, you can see over here like this is MIMO transmitter and this is MIMO receiver is there, which means let us say there are 3 transmitters are connected and there are 3 receivers are there. So, N is equals to 3 and M is equals to 3 in this particular diagram, and there are different bits that are transmitted like B1, B4 and so on, and here this is B3, B6. So, these bits are connected and here a series of bits will be transmitted. Now, this particular data will be radiated by using this modulation and mapping technique. Now, this is been received by a signal processing system. So, there are different carrier signals are there which will going to pass this particular channel, like these are the paths that has to be followed like B1, B4 and so on, this is B2, B5 and so on. So, this is A1, A2, A3 like 4 different techniques are 4 different. This is the constellation diagram at this particular point A1, this is the constellation diagram at B, this is the constellation diagram at C. So, A means for the particular transmitter A1, this is for transmitter A2, this is for transmitter A3. It has followed either ASK, FSK or BPSK technique. It has followed. So, large number of points are there because it will going to receive the signals from multiple path, and here it will be correlated one, means these are segregated ones. So, this is how the spatially multiplex MIMO system looks like. Now, the MIMO channel model is a matrix in mathematical form. You can see that H matrix we have considered. So, there are different parameters of H matrix are there like H11, H12, H13, H21, 22, 23, H31, 32, 33. So, these are the different input signals are there. This is the H matrix, these are the weight function plus the noise. Now, noise will be the additive white Gaussian noise that we have seen over here. Now, this is the value of the approximated value of different weight function, that is the approximated value. This is not the fixed value, which is equals to H inverse multiplied by x1t, x2t and x3t. Now, H is the complex channel matrix. So, these are the different transmitters, like this is transmitter 1, this is transmitter 2, this is transmitter 3 is there, this is receiver 1, this is receiver 2, this is receiver 3. So, you can see the different matrix H11 different parameters H parameters we have calculated over here. Now, to analyze the reception through it, we have to use eigenvectors and singular value decomposition techniques, which will going to calculate the different values. So, this is how the spatially diverse techniques are multiplexed MIMO system look like. Now, I am going to repeat a particular topic again, that is what is joint diversity. Now, in this case joint diversity, like we have seen 4 to 5 different types of diversity technique, like space diversity, polarization, angle, frequency and time diversity. All of them have their own advantages and disadvantages. Now, in case of joint diversity, we have to choose that which particular diversity, what are the different types of diversity that we can combine. Now, it all depends on the particular technique, the advantages of a single diversity technique, like space diversity has their own advantages or disadvantages, polarization diversity. So, in case of joint diversity, it will going to combine the advantages of different diversities and it will going to produce a hybrid type of diversity, which is a combination of one or two. Let us say in case of angle diversity, when the signal will be received at different angles, then it has their own advantage. In case of frequency diversity, the information is transmitted on more than one carrier frequency. So, different carrier frequency that we are going to consider is a cumbersome method, that how we can combine different diversity techniques, but it will be beneficial to use this frequency diversity technique. In case of space diversity, let us say it will going to consider the distance between different antennas lambda by 2, that is half a wavelength, then it is sufficient to obtain two uncorrelated signals. So, this is the different diversity techniques, that is the combination of different techniques that we have shown over here. Now, then we have seen different combining techniques, like we can combine depending on the selection, combining depending on the threshold values that will be preset threshold value will be there at the receiver side. Then there is maximal ratio combining, and then there is equal gain combining technique is there. In case of selection combining, let us say different antennas will be combined together, which is having their different gain values like G1 to Gm. These are the different gain stages. Then here there is a switching logic or demodulators are there, which will going to combine the different values, then it will be received at here this point, that is the selection combining technique. Now, next one is the threshold combining, where threshold preset threshold value will be there, which will going to consider that which particular antenna is having a maximum value compared to the particular threshold value, then it will be compared by this comparator and it will be applied as a feedback to to switch to which of the gain antennas, like this is first antenna, this is second antenna. So, there are n number of antennas which are connected at the receiver side. Next, we have seen the equal gain. In this, all the gains are having the same value, like m number of gains are there. So, m number of branches are having the same gain value. Now, this is passed through this co-phase and some channel. Now, this will be applied as an output to this equal gain combining technique. Now, we have seen three different combining techniques. So, first one, last is the maximum ratio gain, where maximum value has to be selected, which will produce a better signal to noise ratio. Now, this will be calculated by using a detector which is connected in the feedback path. So, this is the maximum ratio combining technique. So, in this particular lecture, we have discussed about different types of MIMO techniques, that is multiple input, multiple output, and also we have seen the diversity technique, like more than one transmitter and more than one receivers are there, then how the data will be transmitted. These are the references that you can consider for this particular topic. Thank you.